The technology, as I have already told, it's gallium arsenide material uses, and all the specification, technical specification is in my presentation paper. If you want to know, you can give a short look about that. The advantages, yes, there are lots of companies around. I mean, nowadays 7 or 8 companies around us are using this kind of technology. I mean, the concentrated photovoltaic system. Some of them are very. I mean, most of the companies are very big. When I was doing my project, so I got some information about the sunflower technology system. It's based on California. They are very famous about this concentrating photovoltaic system. So when I have researched, I found lots of companies, like 7 or 10 companies, like doing these kinds of technology, using this kind of technology for energy production. Better for both industrial and domestic use. Disadvantages, yes. The main disadvantages of this technology is price. Before, if you go, I mean, in past, I mean, the price of these solar cells are really expensive. I mean, you cannot buy those solar cells for your personal uses or for a small investment. So the price was really high. But nowadays, as technologies are improving, the price are getting really cheap, not as much expensive rather than before. So these disadvantages can be. I mean, we can deal with these disadvantages in future because the prices are decreasing. Resource availability. Yes, this is really a big disadvantages, because there are 6 to 7 companies, as far as I have researched, are manufacturing this kind of solar cell. One of them are Azure Space. Those, I have contacted with them and they are agreed to sponsor my project. That's why they have sent me those solar cells without any cost. So yeah, I mean, if you are trying to buy this solar cell, you have to go to those specific companies, because you cannot buy those solar cell just, in a common space. What's the technology behind triple junction solar cells? I mean, these solar cells can be defined as triple junction solar cell. I mean, base material we are using is gallium arsenide. Chip size is really small, like 559, as I said before, 559, 639 millimeter. Cell size is really small, like 032 with the circuit board. They have assembled this circuit board for me. I have used this circuit board, used this solar cell with the circuit board in my project. So it's really small, like 0.032 meter square. Thickness is really small, like 190 micrometer. This is the solar cell, the assembled view of the solar cell. Advantages. Less heat loss. If you consider the traditional solar cell, the silicon-based solar cell, the heat loss is like 20 to 25%. I mean, it's a big matter for energy production. If you have higher amount of heat loss, then the energy production will be not that much of higher you expect. So for this solar cell, it's only 5%. So it's really impressive. I mean, 5% heat loss and getting much more energy from this solar cell. Space consuming, of course, is 0.03 meters square with the circuit board. Efficiency rate is up to 39%. So yeah, it's really higher efficient and higher energy production. These are the main advantages of this kind of solar cell. I have used Fresnel lens for concentrating the sunlight. As you can see in my project, I have used 5 Fresnel lens. These Fresnel lens were ordered from China. So these Fresnel lens are concentrating the sunlight to the solar cell. So why I'm using this Fresnel lens? Because it's small focal length. Focal length is really small, like 220 millimeter. Dimension is 120 millimeter by 120 millimeter. But as you have seen, that I have used 2 kind of Fresnel lens dimension. One is 75 millimeter by 75 millimeter, and one is 120 millimeter by 120 millimeter. Because I was trying to get, was there any energy differences using these lenses? But I was not that much of mine. I will show you in my results. These two kinds of Fresnel lens I have used in my panel. Advantages of the shape. Fresnel lens is I got like $9, so it's not so expensive. When I was talking with the company, they have said if you order much, I mean a big batch of Fresnel lens, the price will be decreased. So it's not so expensive, I must say. Better performance, spherical shape. This is a big advantage because most of the concentrated photovoltaic system has tracking system. We all know that tracking systems are really expensive nowadays, though there are lots of technologies are coming, making it cheaper. But as this is like spherical shape, if you consider the sun rises from east to west, most of the time the same lights are coming to the solar cell, I mean the Fresnel lens. And because of coming the same, almost same light into the Fresnel lens, the concentrating ratio is much more same, not so different from others. But there's only one problem, is when the sun comes from east and when it's in the evening. I mean, that time there will be a shadowing effect. I will talk about in my further work section how can we improve that section. These are the experiment I have done. These are the data sent from the company. I mean, they have tested in their laboratory, but I will compare it in my practical experiment. So if you see, these are the short circuit current and these are the open circuit voltage. So we cannot exceed these much of current or voltage because these are the rated voltage of current. But when we are using the flashlight in the laboratory, I'm getting like, they are getting like 4.334 ampere and 2.589 voltage. So if you are comparing with the rated power, it's not so, I mean, it's really impressive because it's not so less. I mean, it's like 4.421, you're getting 4.334, so it's pretty impressive. So I have tested twice here in the university campus, but I was bad luck. My luck was not good because I'm not getting much more sunlight in this season. So when I'm using these, when I have tested this, the condition was not so good. It was hazy day. It was a hazy day. But there was lots of diffusive sunlight. But still, I was using the resistor value they have sent me. It was 0.67 ohm. So it was like still I'm getting a good amount of voltage and the current. So the power output is really good, like 10.24, where the rated power was like 40. So it was good, in my opinion. These data were tested without using the resistor value they have sent me. I have used a variable resistance that is 6.5 ohm. So I have tested, I'm getting this kind of voltage, 1.79. It was a cloudy day, I must say. There was no sunlight available at all. So it was a cloudy day. But still I'm getting 1.79 volt, 1.95, higher was 2.05, and the test time was 10 a.m. to 2 p.m. So it was okay, in my opinion. These are the photos when I have created my project and the laboratory. And these are the photos. And these are the tested photos when I tested outside. And I used a pyranometer from the laboratory, and the concentration was 304 watt per meter square at that time. I'm not good at SolidWorks, but still I managed to draw this. Maybe we can use this kind of system in the future. Cost. I have talked with the company. They have said that if you order in small amount of receiver, I mean the solar cell, it will be cost €5 per unit. If you order big amount of solar cell, like big batch, then it will be like €2. So it's not so expensive. And structure I have used wood, so it's really cheap. And Fresnel lens, as I told, $9 per person, so it's not much. Further work, yes, increasing the efficiency level. I will use mirror, because if you see that if I put this panel like this, there will be a shadowing effect inside here. As I put the solar cell just here, I mean behind this Fresnel lens. So if I use the lens here, there will be a internal reflection, so that there will be not enough loss of the light. So this is my future, further work. I hope I will able to use this kind of system in future and increasing the efficiency. And using the solar prism, I have talked with some companies. The solar prism price was really expensive, like $200 for solar prism, using the magnesium chloride as a reflecting materials, anti-reflecting materials. So I will use that kind of solar prism, a cheap one of course, to concentrate the sunlight more to the solar cell. If we concentrate more solar light, it will be, the energy level will be higher, of course. Efficient than traditional solar cell. This is, at the very end, I got this kind of stuff. These are my evaluation. Of course, traditional efficient in the traditional solar cell. Good option for larger production. Answer for next generation solar power production can be more effective by using some more technology, as I told, using the meters or increasing the efficiency level and trying to make it more cheaper, because my objective was use this solar panel for the general people, not for a certain level of people, so that everyone can use this kind of solar panel in their house for energy production. That's all. Thank you very much. If you have any question, you can ask me, and I will be happy to answer.